Section 1.7 talks about a circle. Circles are probably the least complex graphs of the conics. So conics, we run into circles, parabolas, hyperbolas, and ellipses. Circle is the most straightforward. An equation of a circle in standard form looks like this, in which the center would be the opposite of those, and the number that you square to get that would be the radius. So the goal is to get the equation of a circle looking like that. Here's one. Write the equation of a circle in standard form and sketch the graph. Well, this is already in standard form. The center would be, the opposite of that would be 2. And you could think of that as y minus 0 squared. So if there's no number there, that means that's a 0. I forgot to put the grid. Okay, fix that. So the center is at 2, 0. So if I move to 2, 0, and the radius is, what do you square to get 9? A 3. So you would move 1, 2, 3 to the right, 1, 2, 3 to the left, 1, 2, 3 up, and 1, 2, 3 down. You connect those with a smooth curve, and there's your circle. Of course, I could use that circle and show a much nicer graph, but this is how you're going to do it on the homework or a paper, and that's acceptable, of course. And if I look at my second equation, well, I notice it's not in standard form. I get the x's together. And what I'm going to do, I'm going to add a number to the x's and a number to the y's to make that a perfect square. So I'm going to take, for the x's, I'm going to take half of the middle number, which is 1, and square it. That makes this x with that sign, the number before I squared it. And for the y's, it's going to be y, I'm going to take half of the middle number, which is 2, and square it. And this is going to be y with that sign, the number before I squared it. And 4 plus 4 is 8, plus 1 is 9. So the center would be negative 1, 2, and the radius will be a 3. So in this case, I would move to negative 1, 2, and from this point I move 3, 1, 2, 3 to the right, 1, 2, 3 to the left, 1, 2, 3 up, and 1, 2, 3 down. And I connect this with a smooth curve, and there it is. Oops. There. And if I get to the next problem, the same deal happens. Let's work that out. Give myself some space. So x squared minus 6x plus a number, plus y squared plus 8y plus a number, and I would need to add those numbers on the other side. Actually, I'm going to shift this one down. I'll put it on the side, I'll come back to it. If I take half of the middle number, which is 3 or negative 3, when I square it, that becomes a 9. And if I take half of the middle number, which is 4, and I square it, I get a 16. So this becomes a perfect squared. That's why it's called completing the square. X with that sign, the number before I squared it was a 3. As for the y's, I'm going to get a perfect squared. Y with that sign, the number before I squared it. And 9 plus 15 is 25. So I have a center of 3, negative 4, and a radius of 5. So if I take one, 2, 3, and run down 1, 2, 3, 4, that's the center. I move 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 to the left, oops, the other left, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And if I connect that with a smooth curve, I'll be looking at a circle that looks like, oh, but it didn't work. Okay, we'll go the old traditional way. There it is. And next example, to complete the square, this needs to be a positive 1. It's not, so you divide each of those by 2. In a circle, you could divide, it's as simple as that. But if it was an ellipse, which we're going to get to, or a hyperbola, you have to factor. We'll talk about that when we get there. So again, let me push this one down. And here we are. So again, I'm going to take this and make it a perfect square. I'm going to take half of the middle number, which is 1/2. So 1/2 of 1 is 1/2 squared. That's 1/4. So this becomes x with that sign, the number before you squared it. And here, I'm going to make that a perfect square. Take half of 3, that's 3/2. If you square it, that's 9/4. This becomes y with that sign, the number before you squared it. And on the right hand side, I notice I have times 2 times 2, 9, 10. 10 plus 3, 16 over 4, which is 4. So I have a center of negative 1/2 and negative 3/2 and a radius of 4. So if I move negative 1/2, we're going to say that's negative 1, negative 1/2, and negative 1.5. If I move 2 units to the right, and 2 units to the left, and 2 units up, and 2 units down, and connect that with a smooth curve, there it is. I wrote the wrong radius, didn't I? The radius is actually a 2. Alright. The other way around, find an equation of a circle. If you give me the center and the radius, well, it's going to be x minus that 2 squared plus y minus that 1 squared equals 3 squared, which is a 9. And there it is. It's fairly simple if you're given those. Sometimes you have to find those. How about if the center is negative 3, 0? Well, that's x plus 3 squared. And since there's no shift along the y-axis, 2 squared is a 4. And what if I have a circle that's centered at the origin? Well, that would be x squared plus y squared, and 5 squared is 25. What if I have a circle that's passing through a point? Well, write what you know. We know that x is going to be minus 1 squared plus y minus 3 squared equal r squared. There are a couple of options. In the book, they kind of use the distance formula. There's a better way. If a point is on the circle, that means that equality is valid. So since this point is on it, then if I substitute the 4 for x, the 7 for y, that should hold. If I throw a 4 in there, 4 minus 1 is 3 squared, and 7 minus 3 is 4 squared equal r squared. That's 9 plus 16. So 25 is r squared. Replace this by 25 and you're done. And it would be x minus 1 squared plus y minus 3 squared equals 25. You really don't need to plot it, but you could look at a basic graph if you wish, or a rough sketch really quick just to get an idea. You're moving 1, 1, 2, 3. Again, this is not part of it. And it's passing through 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So the circle looks something like this. The point is, any point on this circle must satisfy that equation. And if I look at the second part, and this is the last type of problems you would see, and if they ever talk about a tangent line touches the circle at one point only. If you have a circle with diameters -3, -1, and 2, 5, again, this is just a rough sketch, just to get an idea of how things go. The diameter of a circle is a line that passes through the center, and its endpoints are on the circumference, which makes the center the midpoint. So the center for the circle is the midpoint, and if you remember the midpoint, you add the x's, average them, and you average the y's. So the center is -1/2 and 2. Now to find the radius, well, we do the same catch we did there. You could find this distance and call it the radius, or this distance, or you could say, wait a minute, isn't this x plus 1/2 squared plus y minus 2 squared equal r squared? And I could pick either point. Let's say I pick this point. It doesn't matter really. And I would say 2 plus 1/2, right? 2 plus 1/2 is 5/2. And if I take 5 minus 2 is 3, so r squared is 25/4 plus 9, which equals all over 4, that's 36. 36 plus 25 is 61. That would be the equation for that circle. And that's pretty much it for this section. So not always the numbers work out to be integers or, whole numbers, however you want to put it. A lot of times it's a fraction or a decimal, and that happens. Oh, r squared equals 61. I messed up. So cross that out and put 61/4. The radius, if you want, will be the square root of 61. Square root of 4 is 2, but you don't need to find that. It just says find the equation of the circle.